The future engineers, we are on our next problem. This is actually same problem from the previous one, but this time we already have our damping coefficient C. Okay, so let's proceed with our uh, proceed with our solution. Uh, we have is we have the same initial displacement, initial response velocity, and since same naman siya og elasticity, and then the inertia and also the length, so we also have the same, and also the same mass, then same result ato ang stiffness. So ang purpose lang ginato ani is to show you the different condition and then to apply the different equations of motions depending on the type of the free vibration response system. Okay, let's start first. So we have our first problem here as to find the omega natural angular frequency, and then we also have the we're asked to find the damping ratio. So the omega is just equal to the square root of k over m. So dali na lang kayo because we have already our k that is equal to 10,000 Newton per meter over the mass na 5,000 kilograms. So this is equal to square root of 2 radians per seconds, or 1.4142 radians per seconds. Or, kasi iba nung musulat sila 1.4142 per seconds, or 1.4142 s to the negative 1. Whatever be the case, they are all the same, no? So our natural angular frequency omega is equal to 1.4142 radians. Next is you are asked to find what? The damping ratio. The damping ratio is just equal to the damping coefficient C over the critical damping 2m omega. So we have our C here. That is equal to 12,350.262 kilograms per seconds over 2 times the mass of 5,000 kilograms times the omega 1.4142 radians per seconds. Take note no nga the unit of our C is in kilograms per second sa SI, or it can also be written as Newton seconds per meter. Actually, the Newton seconds per meter is, if i-rewrite na ninyo si Newton, Newton is equal to kilogram meters per second squared, and then times seconds per meter. So makancel si meter, and then makancel sa seconds in numerator, and then the second in the denominator. That will eventually go back to kilograms per second. So I'm kalibog if ang gamit is kilograms per seconds or Newton seconds per meter. They are all just the same. So again, our damping ratio, that is just equal to 0.8733. So we already have our answer for the damping ratio. So sa pasabutan ng 0.8733, that is, it means that our coefficient C is 87.33% of the critical damping. Next is, we are asked to find the displacement U at time t. So, if you recall, no, the psi or the damping ratio is equal to 0.8733. That is less than 1.0. Therefore, the system is what? The system is underdamped. Since the system is underdamped, the equation of motion na itong gamiton is for U is equal to e to the negative psi omega t times alpha cosine omega dt plus beta sine omega dt. So si underdamped, no, si undamped condition is medyo similar sa silang equation, but ato lang ginagamit din nga angular frequency is the damped angular frequency, and then there is an addition of the exponential function here. This is if you notice, no, negative na siya pasabot, magkagamay itong value. It denotes decay in our amplitude sa ato ang oscillating or the vibrating system. And then if we differentiate this one, our velocity, we will have, so e to the negative psi omega t times the derivative of this portion here, that is equal to negative alpha omega d sine omega dt plus beta omega d cosine omega dt. Now we differentiate the other part. We have the negative minus omega psi omega e to the negative psi omega t times the alpha cosine omega dt plus beta sine omega dt. So if you notice, no, this function here, this part here, that is just equal to u. So the velocity, we can rewrite that as e to the negative psi omega t times negative alpha. Ato, pwede na po natin ipagawas si omega d. Okay, ato lang ipagawas para malinawon. So we have omega d e to the negative psi omega t times negative alpha sine omega dt plus beta cosine omega dt minus psi omega times u. This is our equation of motion for the velocity in the underdamped condition, and then this is for the lateral displacement. So we just rewrite that. Our u is equal to e to the negative psi omega t times what else? We have the alpha cosine omega dt plus beta sine omega dt, and our velocity is equal to, we have the omega d e to the negative psi omega t times negative alpha sine omega dt plus beta cosine omega dt minus psi omega times u. Okay. So take note that our initial displacement u is equal to negative 400 millimeters, and initial velocity is 300 millimeters per seconds. So may next na ito buhaton dire. So para dali atong life no kanin itong mga nagbalik-balik ng mga terms dire, ato na siyang buhatan og combination. So for the psi omega, that is equal to 0.8733, then our omega is equal to 1.4142. So our psi omega, that is just 1.235. And then our omega d is equal to omega square root of 1 minus psi squared. So we have a 1.4142 square root of 1 minus 0.8733 squared. So our omega d is just equal to 0.689 radians per seconds. So ipapares na nato sila, no? Our psi omega t, so for this condition at 5 seconds na, that is just equal to 1.235 times 5, that is 6.175 radians. And our omega dt, para dali na lang ito pagsulat, is 3.445 radians. Okay. So initial conditions at time is equal to 0. Our u is at negative 400 millimeters. And our v is equal to 300 millimeters per seconds. So with So this equation here will become, we have negative 400 is equal to e to d. So we have that is e to the 0 times alpha cosine 0 plus beta sine 0. Again, our sine 0 that is equal to 0 and our cosine 0 that is equal to 1. So again, we have our alpha is equal to negative 400. Now we can solve our beta. So we can solve our beta from this equation. So at t is equal to 0, our velocity is at 300 millimeters per second times our omega d, which is equal to 0.689 times e to the 0 times negative alpha sine 0 plus beta cosine 0 minus psi omega, so that is 1.235 u. Our u at time is equal to 0 is equal to 400. So we have negative 400 times negative 400. So sine 0, that is equal to 0, then this becomes 1. So we have 300 is equal to 0.689 beta minus, so this becomes plus. So 1.235 times 400, because that is a negative of a negative. So we have here plus 494. So we can solve our beta, which is equal to negative 281.5675. Okay. So we have already our beta and alpha. Then we can substitute this sa to ang equation of motion. Okay. Let's continue. So we have our u is equal to e to the negative psi t times alpha cosine omega dt plus beta sine omega dt. So we just recall, no, psi omega, that is just equal to 1.235 radians per seconds, and the psi omega t, so this is in the 5 seconds is already considered. So the 1.235 and 5 seconds, that is equal to 6.175, and our omega d is equal to 0.689 radians per seconds, and the omega dt is equal to 3.445 radians. Okay, so we can solve now. We have the u is equal to e to the negative 6.175, this one. So ato na lang siya gi-show down diri para di na kayo nigubot diri nga part. And then no, our alpha is equal to negative 400 millimeters. And our beta is equal to negative 281.5675 millimeters. So ano millimeters? Kay millimeters ang unit nga gigamit nato for the displacement, and for the velocity is millimeters per second. So we have minus 400 cosine or omega dt is 3.445 radians. Minus the beta nga 281.5675 sine 3.445. So our u, or the lateral displacement after 5 seconds, is equal to positive 0.9694 millimeters. So can you tanaw, no, from the initial displacement of Negative 400 after 5 seconds. Pila na lang. Last almost 1 millimeter na lang din iyang positive 1 millimeter na dayon iyang displacement. This is because due to the application of our damping. Now for our velocity, don't forget the formula for the velocity is equal to omega d e to the negative psi omega t times we have the alpha negative alpha sine omega dt plus beta cosine omega dt minus psi omega times du. We just substitute this value. Our omega d is 0.689 e to the 6.175. Don't forget the negative sign. Times alpha, that is negative 400 sine of 3.445. So, mas dali siya no kung ato isulat na ng values para di na siya taas. Plus beta, that is minus rather, that is not plus. Minus 281.5675 cosine of 3.445. And then minus psi omega, that is 1.235. Then our u at 5 t is equal to 5 seconds is this one. That is 0.9694. Then we will have our velocity at time is equal to 5 seconds equal to negative 0.6406 millimeters per seconds. Okay, this is for the underdamped condition of a free vibration system, single degree of freedom.